All right, 9-3 day 2. We have another technique in that integration by parts. So 9-3 day 3, no, day 2. All right, so we had the one technique where you let u differentiate until you get 0. Yesterday we had the one, if you didn't have something that went to 0, we could have like a trig function reappear. And now today we're going to have reassociate. And reassociate just means you're going to steal something from the u column and bring it over to the dv so that you can actually do the antiderivative of the dv column. So reassociate part of the u is slid over to the dv column. So we'll get right started with our examples. Let's go integrating x cubed cosine x squared dx. Okay, so right away you see, oh, I've got x cubed. I know that's going to be my u. That'll go to 0. But try not to get too tunnel vision on that. Look over here. When you have cosine x squared, make sure you can actually do the antiderivative here before you get started. If you think about it, with the trig functions, remember, we have to have the derivative of the angle next to the dx in order to go through and do antiderivative. Well, the derivative of the angle is 2x. The 2 isn't a problem. I can hit it with a 1, a 2 and a 1/2, but the extra x here, I don't have. But I can steal one from over here or reassociate one. So instead of starting with x cubed here, I'm going to leave x squared here, take that third x and slide it over next to the dx and throw it away. So now I'm ready. I'm going to go 2x is my derivative. I can do the antiderivative here. Again, I needed an x and I need a 2. So I need a 1/2. So I will have a 1/2 sine, and the angle never changes, x squared. Now I know I'm going to have to do antiderivative again, but I can't until I steal. So we're going to draw a line and reassociate. So that's my first derivative and antiderivative. Now I'm going to start over. This is still my u column, but I know that I have a 2 and an x, and then I've got this 1/2 sine x squared. I'm going to keep the 1/2 sine x squared. I have a 2 and an x. I'm going to steal the x and put it over here off to the side. The only thing that's going to come down here is the 2. So everything on this line has to be on this last line that I had, just reassociated. I'm starting over. So this derivative goes to 0. And then once I do this antiderivative, I'll be all done. So the x is waiting over here. I still need a 2, and I need another 1/2. I don't want to write it there. Well, I guess I could. It'd be okay because I'm not using that on my arrow. But I'm just going to keep it in my head. So I'll have a 1/4. I know this is going to go to a negative cosine x squared. So now we have 2 diagonals. So we got our first one. You never draw a diagonal over the reassociate bar when you're starting over. So I have this, but we still have our last horizontal, just in case that's not a 0, get in the habit. So positive, negative, positive antiderivative. So I'll have a 1/2 x squared sine of x squared. The next is going to be a positive. That'll be a 1/2 cosine x squared. And then the antiderivative of 0 gives us our plus c. Okay, we'll try another one. Number 2. We've got x to the 5th, e to the x cubed dx. So again, u dv. Looks like we want to put the x to the 5th here, but before you get going, look over here, e to the x cubed. So think about this. Again, we need the derivative of the exponent before we can do antiderivative. The exponent derivative is 3x squared. So I've got to steal 2 of these x's or reassociate them. So I'll leave 3 here and put the x squared, excuse me, over here. And now we're ready. So the derivative will be 3x squared. I'm going to stop. I'm going to do the antiderivative here. I still need, see, the derivative of this is 3x squared. I need a 3, which means I need a 1/3. Okay, I'm going to reassociate. Again, everything here gets written down here, but reassociated. So I'm going to keep my 1/3 e to the x cubed. I know the derivative here is a 3x squared. Oh, I could just take all of this and not have to hit it with a 1 and just leave a 1 here. I'm going to do that. So I want the whole 3x squared to be over here. I'm going to leave a 1 here. And then do derivative. And then antiderivative. Everything's set to go. I don't have to hit it with a 1 because I had the 3 to put over there. I'm going to have 1/3 e to the x cubed. So 1 diagonal, 2 diagonals, and a horizontal. Positive, negative, positive. So final answer. We're going to have a 1/3 x cubed e to the x cubed. The next diagonal is going to be minus 1/3 e to the x cubed. Antiderivative of 0. Done. Number 3. Antiderivative of x to the 5th, ln of x, or ln of 4x dx. Okay, so u dv. Looks like we want x to the 5th here, because we know that'll go to 0, or at least start it there. And then over here we've got ln of 4x. Now again, before you get going here, look over here. Can you do the antiderivative of ln of 4x? If you look at your integration rules, nowhere do we have an ln rule. So it is impossible to put the ln under the integrating column. So we cannot put the x to the 5th over here. We're going to start all over and flip them. So anytime you have an ln, it has to go under the u. You have no option. And then x to the 5th will go over here. Let's see what happens. So the first derivative, I will have 1 over 4x times 4. It's going to give me 1 over x. Here I'm going to get, let's see, adding 1, because I'm doing antiderivative, that'll be 1/6 x to the 6th. All right, and if you think about this, this is x to the negative 1. If I keep going, if I try to do derivative, I'll never get to 0. I'm already past I'll be at -2, then -3, then it'll just keep going into the negatives. But take a look at this line. This is x to the negative 1. This is x to the 6th. I've got all x's. I can reassociate now and lump all of my x's together. So I'm going to leave the 1 here. I'm going to bring over the 1 over x with the 1/6 x to the 6th, and just, if you combine all of these are going to cancel 1. I have 1/6. This will become x to the 5th. The x to the negative 1 and the x to the 6th will have x to the 5th. So derivative goes to 0. Over here, add 1 times by reciprocal. So that add 1 and get 6 times of 1. I'm going to have 1/36 x to the 6th. And the 0 there tells me I'm done. So I got diagonal. Never draw the diagonal across the reassociate line. So positive, negative, positive. So my first term is going to be 1/6 x to the 6th ln of 4x. Next one is minus 1/36 x to the 6th, and then we got our 0, our plus c. Okay, so reassociate. Number 4. We've got x square root of 6 minus x squared dx. All right, I'll put x here on 6 minus x squared. I'm going to rewrite that as to the 1/2 power. Now, is this something we can do the antiderivative of before I get going? Well, the derivative of the inside is a negative 2x. I'll have to reassociate and steal this x over, leaving me with 1, which means if I'm starting with 1, that means I can do the antiderivative right back here. I don't have to do integration by parts. So, let's see. Make this 1/2. This is one we probably had before in notes or homework somewhere. I'm going to steal the x, put it over here. I still need a negative 2, so I need a negative 1/2. And now I'm ready for a power rule on it. So I keep the negative 1/2. 6 minus x squared. Adding 1 of 3/2 times 2/3 plus c. So I'm going to have a negative 1/3, 6 minus x squared to the 3/2 plus c. So don't always think that it's integration by parts. Again, if right away you're reassociating and you're left with 1, you could have done it without the integration by parts. Last one. Integral of sine to the 10th x cosine x dx. Okay, so seeing this, I can think power rule because it's sine to the 10th. I'll just rewrite it like this so it's easier. Oh, yeah, definitely one we don't have to do parts with, because if I have the derivative of the inside, which is cosine, I'm going to slide it over and attach it. Don't have to change anything else. All I'm doing is a power rule on the 10 and throwing that away. So it's going to be 1/11 sine to the 11th x plus c. Done. That's an old one, disguised as wanting you to go integration by parts because of the x times the x. But that's it.